I'm going to pick up where I left off on the warm-up problems. And I might make some mistakes, but we're going to fumble our way through this. So here we go. It says, imagine Mayor Bloomberg flies away in his helicopter at the same height for 11 seconds. From 0 to 2 seconds. So that means, what this means right here is that he's just flying. You can imagine it. That here's the helicopter. Sort of. And there it is. It's it's spinning around right here. Okay, that's horrible. But imagine this flying just along a straight line for 11 seconds. So he's not going up or down. His only position changing is this way, and let's say it's in a positive direction. Okay. From 0 to 2 seconds, his velocity changes this way. From 2 to 6 seconds, it changes this way. And it just describes the rest. So we need to draw a velocity versus time graph below for Bloomberg in his helicopter, label and scale the axes. So how do we do this? Well, we know that it's going to be lasting for 11 seconds. So I am just going to be crazy here, and I'm going to put this as time on this axis with seconds. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my god, it's perfect. And now I'm not sure. Well, I can look at this and I can see what his velocity is going to change from. So if it goes from 0, and I see that it speeds up to this, to 30, to 20, to 20. Okay. So I think the highest it goes is 30. So I can, let's see what this is. We've got, if this was increased by 5, that would be 5, 10, 15, 20, 25, 30, 35, 40. That's about right. We could do something like that. So this is going to be velocity on this side. So at this point, it's going to be 5 meters per second. Let's just put this in meters per second up here so I don't have to put meters per second behind every one of these values. 5, 10, 15, 20, right there, 25, 30, 35. Let's just leave it right there. I'm going to switch colors to plum. So it says from 0 to 2 seconds, that's 0 to 2 seconds here, he goes from 0 to 10 meters per second. Now, we don't know how he goes from 0 to 10 meters. He could go very slowly at the beginning and then whoop, speed way up to 10 meters per second. But I am just going to make a straight line just because, or a somewhat straight line, just because I feel like it. There's no other information telling me anything else. So I just make it this up at this point. It could be like a curve like this. It could be a straight line. It could be like going really fast, really quickly, and then slowing, and just the rate of change would then drop off, and so it would just be to 10 meters per second there. It doesn't matter. It's just, it goes somehow he changes from 0 to 10. Then it says from 2 to 6 seconds, he speeds up to 30 meters per second. So from 2 to 6 seconds, he goes from 10 to 30 meters per second. So now he goes like this. And it again, this line could be anything. It could have been like this. It could have been like this. There's nothing in the problem. It could have been like this. Nothing in the problem that tells you it's a straight line, but I just drew a straight line the very first time. It could be any of those. So the important points are right there and right there. Then from 6 to 10 seconds, he slows to 20 meters per second. So 6 to 10, he slows to 20 meters. You just got to hit this mark right here. I'm going to say he slows like this. Finally, he stays at 20 meters per second for the last second. So he just has a straight velocity. His velocity does not change right there. That's the only one that you know is going to be a straight line for sure. So this graph could be anything. It just has to hit these points, this point, that point, and this point, and have this straight line there. And you get full points on that. Now it says draw the acceleration versus time graph below for Bloomberg and his helicopter. Now, this is where drawing straight lines would help. So I'm just going to write over this with a strong color. Let's see. Let's use this red color. I'm going to make these straight lines just to make my life easier. Straight-ish. This is actually the same line. And then I'm going to make this like that, as straight as I can make it. Okay. And this is going to be straight as well. All right. I think this makes sense. From 2 to 6, it's like that. Yeah, okay. So now let's draw the acceleration versus time graph. So it's going to be the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 seconds. And now the acceleration. Now, the acceleration is a little strange because here it's going to have a negative slope. So we're going to have to provide negative values here. And just eyeballing this value right here, I'd say that's if you go down 10 and over, what is that? I don't know what this would be. I'm going to say down 10 and then over, what's this? 1, 2, 3, 4, over 4. So that's negative 10 over 4, which is about negative 2. So I'm going to say that this value, I should have put these seconds up here because that's a typical way of doing the time. But I can make this be negative 3 meters per second squared. This is the acceleration on this graph in meters per second squared. That's negative 3. This could be negative 2. This could be negative 1. That could be 0 as your acceleration. So just make that a 0. This could be 1, 2, 3, 4. All right, I think I got this. So from here to here, let's just choose the point that was told to us. From 0 to 2, you went up to 10 meters per second. So at this point right here, the slope of this line will be the rise over the run. And since I made this a straight line right here, the slope should be up 10 over 2, which would be, I should have done the 5 up to here. So it should be 5. So the acceleration is, the slope at this point is 5. So I'll make that right there. And the slope is the same all the way through here, up to 6. So the acceleration is the same. E accelerates like crazy. It should be a flat line. I could have made that a different color, and I will. It should be blueberry. Blueberry. Now it goes down 10 and over 4. 1, 2, 3, 4. So negative 10 over 4. What is negative 10 over 4? What the hell? Let's see. Let's get a little calculator out here, just because it's late in the day. Launchpad calculator. 10 over 4 is 2.5. So it's negative 2.5. So this is going to go down to negative. This instant right here is going to go down to negative 2.5. That's right there. And it stays the same slope in my graph. 2.5. And at this point, there's 0 on the slope, so it's going to be a 0 right here. So I can make this a line down here if I want to. This has got to be flat because my line right here is flat. The slope doesn't change. And it goes back up like this. This should be what you get. Okay. You make yourself a lot more trouble if you make this into a curved line here and a curved line there. And a curved line there. If they're flat lines, it makes this graph much easier. Okay, that's all I got. Enjoy. Bye.